have in our RNN. So like I said, RNN are flexible in their inputs and output, means you can have multiple, like different combinations of both. So let's look at sequence to sequence, that is many to many. So this is like you give it like 5 words, you give it 5 words and ask it to give you an output, predict the next 5 words you can say, or something like that. So this can be used to like train your chatbots. You know, you give them a question of 5 words, and then you ask for a question answer of 5 words. It could even be 6 words, but yeah, you get the idea. Like many to many, you give it many words, you ask for many words. This can also be used for translation purposes. Like you give it many words, then you ask for many words in return. So, but keep in mind that your data set, which you have to train this on, will have to also reflect all these things. Uh, like it will have to have these long questions along with their answers and all that. I mean, that's the other thing, but I'm just letting you know. So another one is the many to one, which we just saw, which is used in your predictive typing and all that. So you are giving it many words and you're asking for 1 word in return. So you're asking it to predict the next word, which could fit the sequence. And then comes the one to many, which is again similar. You give it 1 word, ask for the next 5 words. So now let's look at a very, you can say, interesting notebook that I've created with Python. So, okay, let's go over to that. I think we might be a bit early on the time. So that's, I guess, nice. I don't know. Keyboard prediction in smartphones, I mean, like they're similar. I'm trying to give you like an example. They're not exactly that RNN, but yeah, but like to give you some sort of intuition of what exactly is happening. So let's go over to the notebook, and so let's look at this. I think it's really cool. So okay, so I have created a notebook. I hear your questions. Okay, stop. I know that you guys want the links for this notebook, so we'll be giving you these links after the session, because I mean, if you guys keep tinkering with this while I'm teaching, you guys will miss what I'm teaching. So yeah, I want you guys to pay attention. That's it. So this is going to be RNN applied on a time series data. Okay. So uh, so what time series data I have taken? So I have taken the time series. So this time series data is similar to the one that we saw at the start of the PPT. Just you can say that it's a little bit more family friendly, I guess. So this is the data for clothing and clothing accessories sales over the years. So let's look at the data real quick. So I got it from this site. You can check that out, and that's where you will be downloading the data set if you want to do this yourself. So yeah, so this is the data set. Okay. So I'll read it using your usual Panda stuff. So now this is the data set. It has data ranging from 1st January 1992 all the way till 10th October 29. Sorry, not 10th October, October 2019. So this is the monthly data. So the data is taken for first of every month, from first of every month, and then they've plotted. Then they have given it to us for every month all the way till October 2019. So the reason I've taken this October 2019 is the reason I've taken this only till October 2019. Uh, we'll get to that later. So this is the data. So now let's plot that out. So over here, similar to that, the wine data set that we saw, there is the trend over here is a bit more obvious than the data set we saw in the PPT. Like you can see, there are these spikes which are like fairly frequent, right? So, and it actually makes sense. Like if you let's zoom into it a little bit. So let's look at this data from the first year. So over here, can you see my mouse, right? Yeah. Okay, so over here in the first year, you can see that there is again a huge spike near the end of the year. So this actually makes sense because this is from the USA. This data set is of the USA. So at the end of the year, in USA, Christmas is pretty big, right? Like, I mean, it's big everywhere, but like we're talking in the context of this data set, in Christmas, people tend to buy each other gifts, and a lot of those gifts turn out to be clothes. Yeah, clothes. I mean, I have nothing against clothes, but like if you're getting me a gift, I would rather them not have. I'd rather not have clothes for as a gift. So okay, that aside. So you can see that actually makes sense that there is like a huge spike at the end of the year. That's because That's the holiday season that people get each other gifts, and a lot of them could be clothes or clothing accessories. So yeah, so what we'll be trying to do is make, so we saw this, okay, we understood this because we know that at the end of the year we have Christmas and gift exchange and all that. So, but our model doesn't know that Christmas exists. Okay, that's kind of sad if you think about it. But yeah, our model doesn't know all this stuff. So we want to let our model know. We need to train our model to pick up these trends, that this spike in December and all that, and that how it's like gradually increasing as well. So what we will be doing is we will be training our model on this data. So to train anything and to test how good it's doing, we have to make a train test split. Everyone knows that. But the difference in this is that whereas compared to your previous stuff that we've done till now using our regression type data set or our classification type data set, is that how do you do a train test split? Like, can you guys tell me, like, is it random or is it like in a particular order? Like, how do you do a train test split? Let me know in the comments. Like, like just for the sake of interaction, go ahead. Like, how is the train test split done in your in other data sets? Yeah, 70/30 random. But main thing I was looking for is random. Yes, because it's randomized. You pick up, even if it's 70/30, yeah, 70/30 usually. Yeah. So the 70/30 is that means that 70% of your data would be kept for training and 30% would be kept for testing. But the 30%, how are we picking that up? How are we getting that 30%? I mean, what does that scikit-learn library do? What the train test split do? It basically picks up random points from your data set and puts them together for our testing data. Yes, random set. So, but we can't do that here because we are working with sequential data where the order matters a lot. I mean, order is the only thing that matters. That's the entire reason it's called sequential data. But yes, it shuffles it exactly. So, but yeah, so what we're doing here, we can't do the same thing which we were doing till now. We can't just apply a random train test split to this and get 30% of the data for our testing. But what we have to do is keep the order intact. So instead of doing the train test split like we usually do using scikit-learn, we'll be doing a manual split. So in our case, we can see that we can observe like a trend after every year. So I think like keeping like 1.5 year as testing would not be bad, would not be a bad idea. So that's what I've done here. We have dates as the data is monthly, so I've kept it like 1.5 years into the future. We'll try to predict the data 1.5 years into the future, and 1.5 years when translated to months comes out to be 18. Hopefully that's not too tough to understand. And based on that, I've picked out the indices, and then I've split the data train test over here based on the indexes that we got. So basically, if you still don't understand exactly what we've done, is basically we have taken about this much, yeah, this much, we divided it here, and we'll be training it based on this. We'll make it try to pick up this trend, and then after it's done with this, we'll try to forecast this. Like we'll have a trained model, right? We'll try to predict what would come after this based on the stuff we are given here. Okay, just a second. I forgot to plug in my charger. Classic mistakes. Okay, now we're back. So that's what we'll be trying to do. So for the last 1.5 years, so we last kept the last 1.5 years of the testing data. We'll be training it on this, and then we'll be forecasting on those, and then we'll compare our values with this guy, with this little section we have set out. So that's what we've done. We split our train test split, and then so you can see our training data goes from January 1992 to April 2018, and right after that we have a test data which goes from May 2018 till October 2019. So now we have to scale our data. I hope we all know why we need to scale our data, so that the outliers don't mess up the model too much, so that our model doesn't give too much preference because there is a huge value. So we scale our data. I'm using the min-max scaler, and then remember that we have to only fit our scaler to our training data so that we don't, leak our testing data. Okay, so we fit it on our training data, then we scale both of them. We transform them using our scaler. So by doing that, we get the scale train, scale test. pretty basic stuff. Now, the next part, the time series generator. Now, let's look at what that does. To understand what it does, I'm going to take you back to the PPT. Okay. So the way we train and test in this, so the way we train our model in this is not like your usual RNN or not like your usual regression or classification type models, because in this, if you see, we don't have that much data. We only have one column worth of data. So how do we do training in this? Because in your previous stuff that you've learned, the regression, classification, you had a bunch of columns that you could work with. You have a bunch of columns that you can work with, and based on these columns, you are predicting a new value, which is in another column. But in this, there are no columns. There is only one column in which there is all your data is put into that. So how do we do that? So we divide the data that we have itself into batches. Okay, wait, we have actually answered this question. Let me just, okay, wait, I don't have presenter on this. Q&A. So, okay, I mean, it's the timestamp's a bit messed up, but whatever. Okay, so going back to this, so now we will divide our entire data that we have into batches. So how do we divide this into batches? So let's look at this. So let's see that this is our entire data set. So let's imagine that we have our data set from 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we separate this into two parts. So the one in blue is the one that we'll be training our model on. So based on these numbers, this sequence, our model would try to predict something. We will give our model these 9 numbers, and we will ask it to predict what would be the 10th number in this sequence. Just like at the beginning, when I asked you to predict the next number in the sequence, we will ask our model to predict the next number in this sequence. So our model will predict something, and then we will compare it with the actual value that will be in the sequence, which is 9 in this case. So based on that, whatever the model predicted, and based on what we have actually, what the actual value is, then it will calculate the loss and then go back and do its thing. The stuff neural networks do. Yes. So the left part, so the two parts which we divided is, one of them is called the training sequence and the other one is called the prediction label. So of course, based on the type of architecture you're going for, you can decide how long both of these can be. So if you want to go for a many-to-many architecture, you can maybe train it to do something like this. You can give it 0, 1, 2, 3, 4, and you ask for the next 5. But for our case, in this case, we only want to predict one in the future, the next one. So we'll be dividing something like this. And also we can create multiple batches instead of just one. But in our case, we'll just create one batch. So 0, 1, 2, 3, and then we ask it for 4. If it gives the 4, then depending on how close it predicts to the 4, it will calculate the loss function and update its weights and stuff. So okay, so now let's go back to our notebook and see how to implement this in code. So okay, so the way we do that is by using the time series generator. Okay, so what does the time series generator do? So like I said, we have to split it into this training sequence as well as the prediction labels. So how much should we split it for? Like over here, we in the PPT, we split it for 4 and 1 over here in this case. We split for 4 and 1. But how do we decide? Like how do we decide how much do we want in each case? So this is where the domain knowledge comes in, or basically common sense if it's a simple enough data set like this one. So in this case, we will be taking, so basically what you want to take in this case is basically some amount in which you can see recurring like trends, like I said, in this case, we can see that the spikes are repeating almost like every year. So I think taking a year as the training sequence could be beneficial, as it would be able to read that entire trend and then based on that make some predictions. So after multiple iterations of this, our model would be able to predict other stuff based on the trend that we have trained it on. So to properly make it like understand the trend, it would be nice that we give it like an entire year worth of training data. That would be 12 months in this case. So that's what we'll be doing here. And in the time series generator, we'll be passing the length as 12. So let's look at what the time series generator is actually taking in. So over here you see I've written scale train and scale train twice. Now why is that? So let me give you an example. So let's say this is I've written the scale train over here because scale train is basic, by the way, uh, the data in which our scaled training data is stored. So yeah, that's where our training data is stored. If you guys forgot for some reason. So let's say we have a data set X and it has 1, 2, 3, 4, 5, 6. And then let's say we have Y that has 7, 8, 9, 10. Okay. So let's say that we have to do a split like that. Batch, we have to create a batch of like three is to one. Like we give it three numbers and then we make it predict the next one. So if our three numbers were to be this, like if we were to take 1, 2, 3 and then ask it to predict the next one, then our testing label, the prediction label would be 4. So this prediction label is in the same sequence, right? It's still in X, right? 4 is still in X. So for this, we can tell it that both of my training as well as the prediction label are in the same sequence. But if you wanted to train it on something like 4, 5, 6, 4, 5, 6, and then the next one is actually not here. So your prediction label for this is in Y. So that's what basically this guy is asking. Where is your training labels? Where are your training? Where is your training sequence? And where are your prediction labels? So that's what this guy is asking. So in our case, we only have one data set. So that's why our both of our training labels as well as the prediction labels are in the same data set, are in the same sequence. But if we had two different sequences, one of them which had the training sequence and the other which had the sequence of the prediction labels, then we would be passing to different things here. But as in our case, this is the both of them are in the same sequence. We have passed scale train on both the times. And the length, like I specified, length basically means how many do you want to take at a time to pass into your model for training. So that would be the length. We have defined it over here so that because we want to use it later as well. So we'll be using the 12 later. Okay, so and the batch size, like I said, you can create multiple batches, but in our case, we only want one. So I won't be messing with that. So I just kept it as one. So now let's check out what the generator actually did. So let's check out the second one. We can also check out the first one, but I can't make any changes to it right now as I'll have to run the entire thing again. So let's check out the second one. So the thing it returns is basically a tuple, and then we can unpack it into two values. So it returns two values. One of them contains the first training sequence, and the second one contains the prediction label. Okay. All right. So to give you guys a bit clearer idea, I've done this printing and stuff. So the first one which we have gotten from the generator is the X. So we have printed it like this. The reason I flattened it so that it comes in a line or else it's like stacked, which makes it difficult to read. So so it's taken these numbers. So what are these numbers and how do we take it? So like I said, we have to maintain the sequence, right? We can't pick up random stuff. So in here, so I've taken the second object. So it goes from 0.021 to 0.0204. So which is like 0.0212 to over here. So if we count these are the 12 labels I've asked it to take as the training sequence length. Like we've given it the value 12, right? So right here. So it took these 12 as one part of the tuple, and that's what we've taken it as X. And the second part of the tuple is the thing that the prediction label. So that is 0.2127505. So that's what it has done. So I hope you guys understood what this uh, generator is doing. It's basically taking in 12 in an order. So actually it's taking in 13 in an order and dividing it in a 12 comma 1. So and the first 12 it's passing into the model. So the model will be like, give me something to train on. Then the generator will give it the first 12. And then the model will be like, okay, I got this. What do I do with this? And then the generator will give it the next one, which it should compare itself to. Then based on that, the basic RNN, the basic neural network stuff. So yeah, so that's what will happen. That's what a generator helps us to do. It basically helps us to split our data into batches and pass it into the model itself. So now that we have created the batches, so now that we have our batches, we are good to create our model now. So let's create the model.